So in this video, we are going to see a problem where provided a positive decimal number, we have to convert that number to a binary. Now, it is something like, let's say 4. 4 is a positive decimal number that is provided. And now, if I run my solution, then I should get 100. Okay. If 5 is there, then my answer should be 101. Now again, this is not 101, this is 101. This is a binary representation, and in order to show that representation, it has been given as a string, which means that the input is a number, type number, but the output is a string denoting 0101 bits, such that that string represents the pattern in which if that number is represented as binary, then that should be like that. So you can see that if I print type of answer, then it is basically a string, right? And 101 is 5, you can understand. So 2 raised to the power 2, so 1 into 2 square plus 0 into 2 plus 1, so that is 2 square plus 1, and that is 5. So you can understand that binary number 101 represents 5. That is fine. Okay, so now we have to see that now why positive. Actually, you can also implement, take your time and implement for negative also, but this question is only for positive, because in case of negative numbers, you have to understand a small concept called 2's complement. Okay, so in 2's complement, so for example, if 101 is there, 101 is there, right? And in 2's complement, we firstly reverse the bit, so I make it 010, right? Okay, and then we are going to see that um, how it is going to be implemented. So for example, if 1 is 0, 0 is 1, 0, and then we add 1, so for example, it will become 0 1 1, right? So but actually, if you directly do this, then you will get the wrong answer. Why? Because the the bits which you are representing, if it starts with 1, then it is a negative number. So somehow, so you understand, so somehow it has to start with 0, and that's why I was saying that you have to read a bit about 2's complement. What happens that actually, when a negative number is there, then it starts with 1. When a positive number is there, it starts with 0. And if I'm saying you only one if I'm saying you that only 101, then actually it means that in 8 bits it is like 5 zeros and then 101, right? Because if it starts something with 1, then that means that that is a negative number, which is actually this case. So you can understand that if 0101, I reverse the bits, then it is 1010, and while taking 2's complement, you add 1 to it, so it will be 1011. Actually, this is a negative number, because which means that it represents something like 1111, like this, and this represents minus what minus 5, and this represents 5. Understand? So you can understand. So just you can study, but now I'm not saying you that I will give minus 5 and then you have to return this string. I'm not saying that thing. You can take it as an exercise and you can implement that, but before that, you have to also understand what is 2's complement, and that you can understand on your own, right? But from our point of view, for this question, we have to just write a JavaScript function such that given any positive number like 1 2 3 4 5 10 18 21, whatever, that should give us a string, and that string should not have these zeros and all. Whatever is like most significant bits or something like this, that is fine. And if it is like, for example, it is 12, right, then it is giving me 1100. So right, so in this case you can understand that 3 bits were there, but in this case 4 bits are there, right? That is fine. Whatever is the most significant bit, starting from there you can return 3. So this is the requirement. No negative numbers, positive numbers, and when we print that, then we should get a string representation of binary. Okay, so this is the requirement. Now you can pause the video and implement such a function such that it returns that string representation of the binary. Okay. Okay, so now let's start with the implementation. So for simplicity, let's directly do a console log. That is fine, and it should give us 1100. But right now our implementation is not there. So just let's say whatever n is passed, that is just console logged. That's it. So nothing is there, just 12 is printed, but somehow we have to convert this 12 to binary string and return that string. Okay, so how to implement something like this? So if we have a number 12, then how do we create decimal, how do we create binary numbers for this? Okay, so the idea is that we keep on dividing the number by 2, right? And whatever the remainders keep on coming, that is that we keep on accumulating. So that is how it works, right? So which means that if first time, so here let's take an example for here also. So first time for 12, when I divide 12 by 2, right, then I get 6. That is fine, but the remainder I get is 0. Next I do 6 by 2, then I get 3, but the remainder is 0. Next I divide 3 by 2, then the integer part is 1, and the remainder is 1. Yeah, so 1 into 2 plus 1, so remainder is 1. And then if I divide 1 by 2, then the integer part is what? 0, and the remainder is 1. And now since integer part is 0, so I keep on doing whatever, it does not matter, right? Because now it will be always 0. So and it will be 0 0 for eternity, right? So this is the last point till which we are interested, right? And you can see that my answer is expected to be 1100, and that is coming from remainders and going from bottom to top. Because you can understand that as you keep on dividing, the first thing you are getting is the units place, the second thing you are getting is like units place means from the right we are getting, right? So this is the least significant 0, and this is the most significant 0, and that's why the answer is from bottom to top 1100. Had it been 13 instead of 12, had it been 13, then 13 by 2, then 6, and the remainder will be 1. So in that case, the answer will be 1101, not 1011, 1101. So that is my answer. Okay. Now, how to implement this thing? So we can implement it in a pretty straight forward manner. What we can do is that so all these numbers we have to keep track, right? Later we have to reverse it also. So why not have an array? And that array is, let's say, initially empty, right? And then what we can do is that while, and let's write that condition of while later. Let's write firstly the body. What we want to do is that we want to push inside array, we want to push this part, this remainders part, which means that whatever n is there, n mod 2, which means the remainder, when you divide by 2, whatever remainder you get, that remainder you push inside array. And then you update the quotient, which means that n by 2, like the integer part of it is the new n, which means that you can understand that n is something like this, n is equal to n by 2. But the problem is that in JavaScript, n by 2 does not give integer. In languages like C, C++, it does. In JavaScript it is. So you have to convert this decimal to integer. So something like number dot parseInt, we know that it can convert a fraction to a number, right? Now you can see that this loop will keep on running. So initially you can see that this will for example for 13 it will give you what? It will give you 1. Firstly it will give you 1, and then 1 will be pushed to the array. Then my n will become n by 2, which means that my n will become 13 by 2 and integer part of it 6. So my n will become 6. Next time again I will push 0, and now my n will become 3. So in that same fashion, then n will become 1, and then n will become 0. As soon as n becomes 0, I don't need to go forward, right? So while n is greater than 0, right? While n is greater than 0, then we have to keep on doing this. Okay. So yeah, so that should be fine. And once we are done, then let's just print ARR. Let's just print ARR, that what is ARR. So this is for 12. Our example was for 13. So let's convert this also 13 for the time being. And let's see. So I'm getting 1011. So yeah, so I'm pushing it from the top down. That is fine. But actually we have to convert the string from bottom to top. So let's reverse this. So ARR dot reverse. If I do this, then now it should become 1101. This is exactly I want, but this is like an array of numbers 0 and 1. I want to convert it to string, right? So why not simply join it? An array join, if you do simply on an empty string, then it will be concatenated, right? So I get 1101, and this is my answer, right? So that is what I am going to return it. So rather than printing, now nothing will be printed, but it will be returned. Okay, and now directly 1101 is returned and obtained here and printed from here. Okay, and you can see that for 13 I am getting, for 12 I am getting 1101, and let's see other values. For example, 3 should be 115, should be 101. So you can understand that these things are working fine, which means that from a number to string representation of binary is successfully done. Okay, so we have implemented this successfully. And one small thing, like so you can understand that n is positive. So n is what, 5 4 3 2 1 whatever. Now as soon as so I am writing n greater than 0. Even if you write simply while n, then what happens, that JavaScript takes a value and sees that whether it is truthy or not. So since I know that n is positive, right, so obviously it will keep on being truthy till it becomes 0. As soon as it becomes 0, then 0 is falsy. So it will be and then for falsy while will not run, which means that while loop will keep on running only when n is truthy, and n is truthy only when n is greater than 0, which means that while n and while n is greater than 0, both will be same in this case, will behave perfectly fine. So you can understand that here also whatever is the expectation, that is fine, right? So that is fine. Now we have got our implementation working. Now let's run a few test cases. So on this link, I will provide this link in the description of the YouTube video. This has a bunch of test cases where you can see that whether your solution is working correctly or not, which means that for 12 it should be this, for 18, for 26, for 92, all these, this should be this. And if you run it and I am seeing that no assertion errors are there, which means that for all the cases I am returning the correct values, which means that my implementation is correct. Yeah, so that will be all for this one. We will tackle one more problem in the next video.